Okay, so we're going to figure out how to design a basic controlled experiment. First thing you gotta know is that I love plants. I love growing healthy, lovely, beautiful plants. But as we all know, plants are very different from one to the next. So, as proper scientists, we had to figure out a few things about plants. So say for example, I get a new flower and I have to make it grow lovely, beautiful, amazing in my garden. I want to know, first off, with my step one guiding question, what will make my new unknown plant grow the healthiest? And there it is growing. Yay! So, step two is I'm going to figure out all possible variables. So I sit and ponder, what can affect plants growing? So think for a second, what can make plants grow differently? You have sun, different amounts of sun. You can have different amounts of water. You can have proximity to weeds or other plants. Your soil type, temperature outside, the use or disuse of pesticides, and maybe even perhaps if there are rabbits in the area that can access your plants. Okay, these are all things that could affect how well your plants grow into strong and healthy plants. So now what we do is, in step three, we're going to list and isolate the independent variable. Okay, so now here on our left, we have all of the variables that we chose. Amount of sun, water, proximity to weeds, temperature, soil type, pesticides used, and animal access. But what we want to do is we want to only isolate one and pick one of those so that we can really key in on it. In this case, we're going to pull out how much water. And this is going to be our independent variable because we made it independent of all the other variables. Those other variables, however, are very important because what we're going to do is not change them. Those are going to be what are called constants. Step four. How are we going to use, or how are we going to measure this? All right, so back to our original question, what will make my new unknown plant grow the healthiest? Okay, and there it is. We could measure, say, how tall it is. We could measure, say, how many petals are growing on the plant. We could also measure how big the flower is. But either way, we have to come up with some form of data to be our dependent variable. All right, and this data is very important because, as Adam Savage says, remember, the only difference between screwing around in science is writing it down. And he is a fun guy who loves his job. So yes, science is fun. Writing it down is fun. Recap. This is what we're going to do. We are wondering how our new plant will grow the best. That's our guiding question. We have figured out our independent variable. How much water are we going to put on the plants? We figured out our dependent variable, or the data we're going to collect, which is how tall the plant gets. Actually, I just chose that off the top of my head. And our constant are all the other variables before. So now we have groups 1, 2, and 3. First group, we're going to give it standard 5 cups of water a day. Most plants kind of like 5 cups of water a day, say. We're going to give another group a little bit more water, 8 cups of water a day. And we're going to give another third group lower amounts of water so we can see higher, lower, and normal amounts of water. Again, the purple is our independent variable. So our blue is our constants, and these will all be the same for each group. This group, however, is kind of important. Because we know it's a standard, or because we know that most plants like 5 cups of water a day, this kind of gives us a known, or a group that we have seen the same results for. So this is what we'll call our control group, and we're going to use this to compare our other groups to see if there's any positive or negative results. Finally, we have to collect our data. The best way to do this is a table. You'll notice that I have amount of water on the left, and I have the height of plant on the right of this data, or this table. So our independent variable usually is going on our left side, and you can see standard 5 cups per day, higher 8 cups per day, and lower 2 cups per day in the columns below it. And our dependent variable, or the data we are collecting, the height of the plant, is on the right side. And that's it. So from this, what we can see is that our lower 2 cups a day actually allowed the plant to grow higher, which is cool. So that gives us some further knowledge about our plant. It likes less water. Now this is key. Remember, the difference between screwing around science is writing it down. So the more you write down, the more sciencey you are. So let's see if we can extend our table. So again, on our left-hand side, we have our amount of water. That's our independent variable. And then on the right hand, we have several columns of our dependent variable because we're going to take it over several weeks. Now the cool thing about this is our initial finding was after week 1 that 2 cups of water was the best. But if you look at the data trending, interesting. We have that 8 cups of water in the long term is better. Okay? So this is why writing more information down or more data is better. Okay? Because it gives you more information to pick and choose from. Because this, my friends, is science. This is where we are going through a stepwise function to gather information to allow us to overcome obstacles and turn problems into solutions. Because science is life. Thank you.